Let's take a look at how to simplify another expression involving positive and negative exponents. This time we're going to simplify 4x to the negative 7th y to the negative 2nd divided by 20x to the 4th y to the negative 10th, all raised to the negative 3rd power. Wow, it looks kind of intimidating at first, but don't worry, we're just going to follow our steps. Recall the first thing that I like to do is I like to deal with anything in the parentheses and apply the power rule to it. Now this might be different than another method that you've seen in a textbook or in another video presentation, but that's the method I kind of like to use first. That is, I'm going to take this power negative 3 and apply it to all the factors within the parentheses, everything that it applies to. So the rule that allows us to do that, again, is the power rule. So I'm going to apply the power negative 3 to all of the factors inside. So that means I'm going to have 4 raised to the negative 3rd power, x raised to the negative 7th to the negative 3, and recall by the power rule, when you have a power to a power, you multiply exponents. So that's simply going to be negative 7 times negative 3, which is positive 21. Y raised to the negative 2nd to the negative 3rd, which is y to the positive 6th, all divided by 20 raised to the negative 3, x to the 4th to the negative 3, again we multiply, so that gives us x to the negative 12th, and then y to the negative 10 to the negative 3, which is y to the negative 10 times negative 3, or just y to the positive 30. So applying the power rule distributes effectively that exponent to all of the factors inside. Now that that's complete, I like to use the negative exponent rule next, which is I like to get rid of all of my negative exponents. You don't have to do this, but I like to get rid of the negative exponents so then they're just positive and I can work with them from there. So there are 3 bases, 4, 20, and x, all of which have negative exponents. So we're going to apply the negative exponent rule to those bases. Recall that the negative exponent rule allows us to take any negative exponent and make it positive by simply moving the base from numerator to denominator or denominator to numerator. 4 to the negative 3. Since the 4 has a negative exponent, I'm going to bring that base of 4 down to the denominator and make my exponent positive. X to the 21, y to the 6th. Those are both positive exponents, so I'm just going to keep those on top. X to the 21, y to the 6th. Now 20 is a base that has a negative exponent, but it's in the denominator. And if we did a little bit of math, you would discover that the negative exponent rule allows us to take a base in the denominator and move it to the numerator and make that exponent positive. If you're interested in seeing why that's true, I can do something for you in a different video. But for now, just accept that it is true. So we'll take 20 to the negative 3 and take that base and move it up to the numerator. Likewise, x to the negative 12th. X is raised to a negative power. To get rid of the negative power, we're going to take the denominator x and move it up to the numerator and make our exponent positive. And finally, y to the 30th, well, that's a positive exponent, so it just stays where it's at. So the only bases that we've moved are the ones that have negative exponents on them. Now, finally, we can simplify out our exponents, and then we can also combine. Let's go ahead then and work out 20 to the 3rd power. Recall, if you have a value raised to an exponent like 20 to the 3rd, this simply means 3 factors of 20 multiplied together, or 20 times 20 times 20. And 20 times 20 times 20 is 8,000. So we'll simply put 8,000 in place of 20 to the 3rd power. I also want to work out 4 to the 3rd power, or 4 cubed, and that is 3 factors of 4 multiplied together. 4 times 4 times 4. And 4 times 4 times 4 is 64. Let's put the rest back in. So we have x to the 21st power, y to the 6th, x to the 12th, over y to the 30th. And the last step then for us, well, actually there's two steps. The first step is to take these coefficients, 8,000 over 64, and reduce them if we can. And then combine the powers of x's, because they're two like bases next to each other, and the powers of y's, since they're like bases divided by each other. So let's start by taking 8,000 over 64, and let's reduce. Let's rewrite our expression up here. So we have 8,000 over 64, and if you divide that, you'll discover that 64 goes into 8,125 times. So now let's work with x to the 21st, x to the 12th. Now you have two like bases. They're being multiplied, so we have to use our product rule. Recall, our product rule told us that if you have like bases, you add the exponents. So x to the 21st, y to the 12th, we will add those exponents together, and we'll get x to the 33rd power. Now, 8,000 over 64 had reduced to 125 over 1, or 125. X to the 21st times x to the 12th combined to give us x to the 33rd. So the last thing we have to concentrate on are the powers of y. Y to the 6th over y to the 30th. This time, when you're dividing like bases, you're going to apply the quotient rule. And recall that the quotient rule told us if we're dividing like bases to subtract our exponents. Now, we talked about in another video I just did that if you have two like bases and the exponent on the denominator is larger, then when you subtract, your answer must remain in the denominator. So y to the 30th and y to the 6th, when you divide those like bases, you're going to subtract 30 minus 6. You're going to get y to the 24th. But that has to remain in the denominator because 30 is larger. So altogether, our answer simplifies to 125 x to the 33rd over y to the 24th, and there's nothing else we can do, and so we're done. I will make one final statement that there are a lot of ways to simplify expressions involving positive and negative exponents. Some people like to simplify things in the inside first before distributing in the -3. They would combine the x's, combine the y's, and simplify 4 over 20. You're welcome to do that. Good luck, and if you have any questions, be sure to email me.